Hey everyone, in this episode we want to talk about the general approach to electrospinning, including how to operate the device and important points you should pay attention to. I hope this video is useful and helpful for you and that you'll share it. First of all, we need to know where we want to do electrospinning. Since I am currently a student, I consider my own university to be a suitable option. However, you can find and use the electrospinning equipment available at universities, research centers, and companies. In some cases, you will only be provided with services and you simply pay for the product you receive. In other places, you may be allowed to use the device as an operator yourself, and the cost will be based on your hours of usage. In our laboratory, there are 3 electrospinning devices that require an appointment to use. I choose this device for the video because it didn't have an active operator. Remember, the first step for electrospinning is solution preparation. You need electrospinnable solution in advance. Here I am preparing a solution of polyurethane and THF alongside alginate and water solution. Keep in mind that solution preparation is a delicate and precise process that may require a significant amount of time for calculations. Start the solution preparation process based on similar articles using a digital scale and several laboratory containers such as vials. If the prepared solution is still not suitable for electrospinning, you can adjust the weight percentage of your desired material in the solvent, either increasing or decreasing it. Repeat this process until you achieve the ideal ratio for electrospinning. However, we want to focus more on the second part of the work, which is starting the process with the electrospinning device. Great, here you can see an electrospinning device that I will be working with. I can say that electrospinning has one of the simplest processes. Typically, to start, you just press the power button. The electrospinning section is usually housed within a chamber that prevents the solution from spraying into the outside environment and ensures proper connections when voltage is applied. Each electrospinning device has a computer system that allows you to adjust the settings. We don't need to worry about the first tab. Let's go to the second tab, which is related to syringe settings. The important button here allows you to switch the needle from pump A or pump B. This device has 2 pumps so that you can perform coaxial electrospinning, or what we call core shell. However, for now, we will only be working with 1 pump. The buttons for pump A and pump B at the bottom are for activating the pump for electrospinning. Once your settings are complete, you can click on the desired pump or pumps. Here we specify the voltage for the spinners as well as the resolution, or in other words, the speed measured in RPM. We also set the speed related to the movement of the spinner, determining how much it should move per minute, along with other settings. This is for fan, and this for the drum collector's rotation. I want to move the spinner arm forward or backward using the same buttons I mentioned earlier. This is usually necessary when you want to place or remove the syringe containing your solution. Here you can see the equipment for applying voltage, which is quite simple. You can apply voltage using the power button and choose whether the voltage goes to the x-axis or y-axis. However, some devices like this one have safety measures in place, so you cannot apply voltage when the device is open. Voltage is only applied when the device is closed. And of course, you can adjust the voltage up or down. It's normal to hear a sound similar to a whistle when the voltage increases. To place the syringe, you need to lift this clamp, which is generally difficult to do with one hand. your device may have a different mechanism instead of a clamp that allows the syringe to be securely positioned in place. I bring this lever forward until it reaches the back of the syringe. First, we need to ensure that there are no air bubbles inside the syringe. We can push the lever a bit further to allow a small amount of the solution to come out. Now, by connecting the metal clip to the needle tip, we create the conditions for voltage difference between. We close the door and turn on the desired pump. In this case, pump A. We adjust the feed supply to an acceptable level and briefly check the settings. If the electrospinning process does not proceed well, we can change any of these parameters. However, two key factors play a crucial role in ensuring a successful start to electrospinning. First, the solution preparation process, and second, the applied voltage. The feed rate and the distance from the needle to the collector are parameters that can affect the quality of electrospinning, but not its initiation. Here we see that the electrospinning process is in the form of spraying, which means that one of the two factors I mentioned, either the solution preparation or applied voltage, needs to be adjusted. Otherwise, you won't obtain fibers. Instead, you'll just get polymer droplets. Remember, when the voltage is applied, do not place your hand near the spraying area, as there is a risk of mild electric shock, which could harm you. Look, when I cut the voltage, the solution slowly comes out as droplets. But when I connect the voltage, spraying occurs. This indicates a successful process. That was the overall process of running the electrospinning device. Once we finish our work, we push the pump lever back so we can remove the syringe. This is the other pump I mentioned that can create a core shell structure by connecting with the first pump. Here you can see that after adjusting the solution preparation process, we now have a better start for electrospinning. The solution is dispersing in the form of fibers as well. When this spider web-like structure forms at the end of your syringe, it indicates that there is an issue with your solution preparation process. Here you can see the foil that I placed, and the surface of the foil has turned white, which means that electrospinning has occurred on it. However, I'm not sure if the fibers have formed properly. I need to check this in another way. One method to determine this is to stick a slide onto the collector and then electrospin for a few minutes. After that, you can observe the slide under a light microscope to see if the fibers have formed well or not. If, as you can see, the fibers are not forming properly, you need to reconsider your solution preparation process or adjust the parameters of the device. This process is called electrospinning parameter optimization. Thanks for watching. Please share it and feel free to send me your comments and questions.